Yo, what is going on? It's your boy, back again with another maths video. Okay, today we're looking at section B of the function notation part of the specification, and this part is relatively easy compared to last video. What we're going to do is translate the diagram that we came up with last time into something mathematicians like a little bit more. For example, we could take f of x and say this is equal to x. It might look a little bit complicated at first, but once we play around with it a little bit, it might make a bit more sense. So the idea when we're asked to find f of x of a particular number, we substitute that number for x. So if we're looking at f of 1, we substitute 1 for x here and here. So f of 1 will just be 1. If we do that for 2, substitute 2 in for x, and we'll get 2. We can do this for any value of x. Okay, so some of you might be thinking, this is actually quite simple. Well, let's turn it up a notch. So if we have f of x equals x squared plus 1, what will f of 1 be? Bear in mind we're still substituting 1 in for the x value. Quickly pause the video if you have time and try and find the answer yourself, and then I'll go along with it explaining my reasoning to the solution. Okie dokie, welcome back. If you did go away, most of you probably didn't, but that's okay. So now we're going to substitute 1 for x, and this will be 1 squared plus 1. And this is going to equal 2, because 1 squared is 1. Let's again come up with a more complicated example. F of x equals minus x cubed plus 2x squared minus 5. Again, if you want, pause the video and tell me what f of minus 1 is and f of 2. Let's see if you can do that. Now, again, we're still substituting for x and this doesn't change, so make sure to put minus 1 in brackets because powers can do interesting things to minus 1, and we don't want to get the minus modeled up with the minus 1 coefficient of x to the power of 3. And then we substitute minus 1 in for the x in the x squared, and then we just have minus 5 on the tail end of the function there. And if we evaluate this, this is going to be minus 1 to the power of 3 is still minus 1, and then we're going to add 2 times minus 1 squared. Now minus 1 squared is 1, so we're adding 2, and then we're just going to take away 5 from the end there. And if we bring this down here and carry on evaluating it, minus 1, negative and a negative is a positive. So this is going to be 1 plus 2 minus 5, which is going to be minus 2 overall. So if you got that, fantastic. If you didn't, that sucks, man, but like next time we'll get it. The key to these sort of questions is just repetition and practice. So this was minus 2, and let's try f of 2 now. So this is going to be f of 2 to the power of 3 plus 2 multiplied by 2 to the power of 2 minus 5. And this is going to be minus 2 to the power of 3 is 8 plus 2 times 2 to the power of 2, which is 2 times 4. 2 times 4 is 8. So minus 8 plus 8 minus 5. Minus 8 and 8 cancel out, so the result is minus 5. And There we go. To wrap this section off, I want to talk about this notation. And this is exactly the same as f of x notation, except we don't put the x in parentheses and we use the fancy arrow instead of an equals. Apart from that, there is absolutely no difference between that notation and the f colon notation. It's just that some mathematicians like using the f of x notation and some like using the colon one. I have no idea why. It's just one of those things. And so we would rewrite something like f of x equals x plus 2 as f colon x equal, oh, not equals, maps to x plus 2, and they are exactly the same. You put in the same number into them, they give the same output. So yeah, that's function notation for you.